Subtraction using sines and cosines. So here we are with the same example we did earlier with x and y components, this time using sines and cosines. Same numbers, 30 meters per second, 45 degrees east of north is my final velocity. My initial velocity is 15 meters per second west. So using the sines and cosines, the basic idea is you make a triangle, you solve the triangle to find out the magnitude and the angle. Keeping in mind that when doing vector subtraction, I go v2 minus v1, which is the same as v2 plus negative v1, right? So I'm going to add the vectors, but I have to add negative v1. Negative v1 will be 15 meters per second east. Remember, you just change the east to the west and the north to a south. Well, in this case, it's just east. So, just seeing what that looks like. Here's my magnitude 30. My first vector is the purple. That's v2, 45 degrees east of north. I'm adding my negative v1, so it's heading towards the east. My blue is where I started drawing to where I finished drawing, right? It's my overall, my resultant vector, and I'm just calling it C, so I don't have to write v2 and v1 all the time. Just looking at the angles, so this is definitely 45 degrees. I just drew a little theta in here because we're going to have to find that later. I figured out that this is 135 degrees. The way that I did that is that first you've got a 90 degree right here. If you follow my mouse right now, in here is going to be 90. This little red dot is 45 degrees, and the reason it is, and please watch my mouse, here's a Z. So I have this to here to here. There's a big Z rule, Z pattern. So that means that that dot and that 45 degrees have to be the same. So the dot plus the 90 is 135, and that's how I got the 135. Okay, so using cosine law to find the magnitude of C, works out to 42, which is the same as we got last time, of course approximately equal to. And then I'm going to use sine law to find this theta right here. And once I know the theta, then I can say, because I really want to find this blue, right? So it'll help me figure out what the angle on the blue is. But first I got to get the theta. So sine theta over 15 equals sine 135 over 42. Let's see how I got that. Because sine theta over the one across from it is sine 135 over this, which is 42. End up with 15 degrees. So if I want to name my final angle then, I sort of scrolled in here, just on this part here. I had 45 here, and this is 15 now, and I want to find the angle on the blue. So I can then say it's going to be 15 plus 45, or 60 degrees away from the north axis, right? So this whole bit's 60. So 42 meters per second, 60 degrees east of north. And I can check mark that because my last answer was 42 meters per second, 30 degrees north of east, which is the same vector. So just by the length of the video, by the way, you can see how much easier using sines and cosines is, because it's about half as long of a video, half as many steps.